if there is no collision, the frame is delivered successfully. So what happens that suppose A launches its frame. Okay, so you can see here, this is at time t1, A started its frame, it launches its frame in the network, right? But at the same time, just before the first bit of this frame reaches to the farthest end of the network, at time t2, station C also feels that it should start the transmission, right? So C also initiated the transmission at time t2, and both of the frame gets collided over here. Collision occurs here, right? So at time, so once the frames are collided, the station which is nearby, which hears the collision, how the collision is being detected, there will be a sufficient change in the energy level of the signal post collision. So once the station senses that the collision has occurred, so the nearby station which detects the collision first, it sends out a jamming signal, and by the time, and then after some time, this collision reaches at A comes to know that a collision has taken place, right? So this is so it about it further transmission. So whatever, it is not that the entire frame is collided. It is what when the A was in the when A was transmitting its frame, at the same time the collision has happened. So it will stop its transmission. Okay, it will avoid its transmission because it comes to know that a collision has taken place, and the nearby station, suppose B or C, anyone which detects the collision, which hears the collision, sends out a jamming signal in the network so that the other stations will know that they should avoid transmission during this period of time, right? So this is what the collision occurs, and how the collision is being detected, because as you know that in a baseband bus that the signals, that the data bits travels in the form of voltage pulses. So whenever the collision occurs, it results in the higher energy levels, the voltage level increases post collision, and that resulted in the detection of the collision, right? So the jamming signal is important, and then what strategy one should adopt, right? For retransmission, once A knows that the collision has occurred, so how long it should wait before retransmission, or it should immediately retransmit? What is your view? What is your view that what the station A should do? Yes. Bolo? So if suppose you see that the two frames were collided, A and C, the frames from A and C were collided, and both of them needs to retransmit their frame. So after a certain period of time, they decided to retransmit. Suppose there is a possibility that both of them may initiate the retransmission at the same time, and again they will collide, right? So there is a possibility, huge possibility, and other stations are also in the fray. They may also initiate transmission at the same time, and that may lead to further collisions, right? So how this possibility can be avoided? So there is a term called binary exponential backup that I explained to you yesterday, that every time a collision is faced by a station, it has to wait for a longer period of time, because both the stations should now wait a different amount of time so that the possibility of collision can be avoided, right? So both the stations will wait for a random amount of time, not exactly the same amount of time, and that will reduce the possibility of collision, but the possibility of collision cannot be denied, right? So how does it work? So as you can see that this is the flow chart with k equal to 0. I will explain what is k. So you can assume that k is the number of attempts. Okay, that a station will the station will try for retransmission, that how many times a station can retransmit. That is there is also a upper bound on that before giving up in case of the station faces the collision. So right, so it applies one of the persistent method. I told you that CSMA CD uses one persistent strategy because it shapes the bandwidth, because in non-persistent there is a wastage of bandwidth because the stations wait for a random amount of time even though the medium is idle. But in this case, in case of a one persistent, the station senses the medium and transmit immediately once the medium is free, right? While in P persistent, that was the third strategy. That is, you can say that exploits the advantage of both one persistent and non-persistent. But the value of P, right, plays a very major role there. That what should be the value of P? So if the P value is larger, right, there will be more number of collisions. But with a small value of P and in lighter load conditions, there is a possibility that the stations has to wait for a longer period of time for transmission, right? So this is this CSMA CD uses one persistent algorithm and then it transmits its frame, right? So there is a possibility because the station in CSMA CD, because to detect the collision, the station has to sense the medium first. If the medium is idle, it has to start transmission, and at the same time it has to keep hearing the medium whether the collision has occurred or not, right? So station has to transmit and hear for any collision if it is occurring, right? So it is you should read transmission done or collision detected. If the entire, because you know that this in CSMA CD the frame transmission time is higher than the propagation time. So the moment the station launches its frame in the network, the first bit of the frame reaches to the farthest end of the network, so that all the stations which are there in the network will know that this particular station has already seizes the medium, so they should avoid transmission during that period of time. But still, if some station which has not heard transmission from, suppose if I am saying about station A, if A has initiated the transmission, but there may be any station which has not heard the transmission of station A and may initiate transmission, and that may subsequently result in collision, right? So how this can be? So the station has to keep sensing the medium and keep hearing the medium for any collision while it is transmitting. So if it completes its transmission, that means there will not be any collision. But if the station is transmitting at the same time, collision is detected, right? So transmission done or collision detected. So if there is no collision detected, okay. So till then, if there is no collision, transmit and receive. So it is transmitting the frame and it is hearing for any collision, okay. Or if the collision is detected, yes, then collision detected. If there is no collision, the frame transmission is done, right? If the frame transmission is done and no collision is detected, it's a success, right? Otherwise, if a collision is detected, it sends a jamming signal. So what this block means, is it clear? That the station has to keep listening to the medium while it is transmitting, so that if any possibility of collision is there, In case of collision, it should stop transmission of the frame, right? Jaise in earlier cases, if you compare it with Aloha, right? Where in Aloha, what I told you, that if a station transmits a frame, entire frame, and then wait for the positive acknowledgement. So if collision occurs, how the station comes to know that if during the round trip propagation time, if the station doesn't hear any positive acknowledgement from the receiver, it assumes that a collision has taken place and it retransmits the frame. So you see that the efficiency of Aloha and slotted Aloha was low because the entire frame was transmitted, and if it is collided with another frame, the entire frame needs to be retransmitted, right? But in CSMA-CD, the entire frame is not retransmitted. Rather, we transmit, because the collision, if in between during the frame transmission time, if the collision has occurred, right, that will only occur in the beginning if the station has not heard about the transmission, right? Because once the leading edge reaches to the farthest end of the network, all the stations will know that some other station is already transmitting, so they will not transmit, right? The medium will become busy, so no other station can attempt to take over the medium. But in case, so only the some portion of the frame will be garbled, right? So it sends a jamming signal and increases the value of k to k plus 1, where k is the number of attempts that a station can make for successfully transmitting the frame, right? And TP is the maximum propagation time, and TB is the back off time, right? So this k value is increased from k to k plus 1, and we check whether the maximum number of attempts, because there may be a possibility that the station has initiated the retransmission and once again collided with some frame, right? Because at the same time, when the station is transmitting, the other station is also transmitting, so there is a possibility that they may again result in collision, right? So every time a station faces collision, this amount of time that it waits for again attempting increases in the exponential manner. So once the k is, so we increase k to k plus 1, means now this is the k has become 1. So it is not maximum number of attempt, k max is set to 15. So a station can possibly try for 15 times before giving up, right? So if it reaches its maximum number of attempts, it will abort. It will give up. It will not try further. So if it has not reached the maximum limit, it will choose a random number r between 0 to 2 to the power k minus 1. So k is 0 this time, right? This time k was 0, so it will wait 2 to the power 0 minus 1. So it will wait for TB will be equal to, because r is to be chosen between 0 to 2 to the power k minus 1. So this is r is nothing but a random number. Random number lies between 0 to 2 to the power k minus 1. So k value will be dictated by the number of attempts. Every time this number of attempts increases, suppose this is the third attempt, so 2 to the power 3 minus 1. So that means 7 round trip time it has to wait. 7 into TP it has to wait, right? And if you are going for a 8th attempt, it will be 2 to the power 255 into TP it has to wait. So every time you see that the station fails to retransmit, every time it is facing a collision, this back off time is increasing. So you can see that this back off time increases in an exponential manner, 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3, like that. So every time it increases like 0, 2, 4, 8, 16, 32, 64, 128. So it will increase in a exponential manner, right? So wait TB time, and then the station has to wait for TB time. Why the station has to wait? because if a collision has occurred, every time, because if collision occurs, the station has to wait, because if it again retransmit, there may be a possibility that the collision may occur, and there are a number of stations, they may initiate transmission during that period of time and may result in collision. And if collision occurs, the two stations who were collided may again initiate at the same time and may result in collision. So just to avoid that possibility, the stations will choose a random amount of time and will wait for a random amount of time to avoid this collision, right? So, but this collision, this binary exponential backoff basically, and then creates a kind of a LIFO. I told you yesterday. What is LIFO? Last in, first out. So if you have a stack of books, what happens? The book which is at the bottom comes out last. Okay, while this book was placed first, but it comes out last. While the book which was placed last comes out first. So that creates a LIFO because the station which results in collision has to wait for a longer period of time as compared to the station which doesn't face any collision. So in that case, it creates a kind of a LIFO. Every time in case of a collision, this duration increases and station has to wait for a longer period of time, right? So then it waits for a back of time, and then once again it apply the persistent strategy, and then once again start doing the transmission, right? So this is the flow chart of a CSMA CD. So what is last in first out, as A's frame has collided two times. So if I give you an example like here, that suppose A transmitted its frame and B also transmitted its frame, so they collided, right? A and first A initiated its transmission and C also initiated. A and C collided, right? A waited for random amount of time, and when it initiated, it collided with B, right? So A has to wait, then A has to once again wait for a longer period of time, 2 into TP, while B will wait for 1 into TP. So in that case, if you see that the station with more number of collision has to wait for a longer period of time. So that is what the last in first out. Now there is another thing that is very important, that this collision detection, because of collision detection mechanism, that puts a limit on the maximum length of the bus length, right? Baseband bus length. Because why it creates a issue for this? Can you say why there is a limitation on the cable length? Because cable length is restricted to maximum 500 meters to detect collision. Why? Because if the cable length is more, and if the collision occurs at the near the farthest end, okay, as you know that the signal strength falls off exponentially once it travels in the medium. So once it reaches at the farthest end, the signal strength is too weak, and once it collided with the another frame, right, it will not make a substantial change in the signal strength post collision. So so the station, nearby station, will not be able to detect any collision, right? So that puts a limit on the maximum length of the cable to 500 meters. If you have to go beyond that, you have to connect, you can divide the LAN into different segments and connect it through repeaters or bridge or layer switches, right? So the upper limit on the maximum length is due to the fact that once you are increasing the length, okay, once you have a very longer length network, what will happen when the signal is traveling from this end to the farthest end, as the signal strength will fall off exponentially, and once it collided over here, it will not make a sustainable uh, change in the energy level so that it can be considered as a collision, right? So this will remain undetected. So that is why there is an upper bound on the length of the cable in case of a like Ethernet, in case of Ethernet cable also, which uses bus topology, right? So this is about the bus topology. Okay, how will you detect a collision in case of a star topology? Anyone can say? How will you detect a collision in star topology? Bus, we have discussed that the voltage pulses, it travels in the form of voltage pulses. Once collided, it will result in substantial higher energy levels, so that the station can detect it. But what about the case when if you have to do it in case of star topology? Any answer? Say it quickly. And I am finding that only maximum up to 35 students are coming. So I have noted down who all are not coming. So I'll write a mail. Okay. Can you say what will be the case in case of a star topology? Huh? See here, in case of a star topology, there used to be a hub at the central place, and there are other stations. And from the stations, there was an issue that we separate out a transmission and reception wires, right? The station is connected with bidirectional way, like there are two wires running from the station to the hub, one for transmission and one for reception, right? So if a station transmits, if the two station transmit at the same time, suppose station 1 and station 3 transmits at the same time to the hub, what will happen? This hub will know that it is receiving signal at two of the incoming lines, right? Generally what hub does, the hub receives the signal from station 1 and send it to, if it is a hub, like you can say it is a connector, or you can say if it is an active hub, it regenerates the pattern on all the outgoing links except the incoming link, right? But once this hub detects that the presence of the signal on more than one incoming line, what it does, it uh, it's it generates a collision presence signal. Just like a jamming signal, it sends a collision presence signal on all the outgoing links, right? So once the collision presence signal, because the collision is occurring where, in the hub itself, and it sends a collision presence signal to all the outgoing links. So the station will know that a collision has taken place, and for some time they will not be allowed to send anything, and then they can resume their transmission after that. So anytime this hub finds that it is receiving signal on more than one line, okay, it generates a collision presence signal on all the outgoing line links, so that all the stations know that there is a collision occurred in the hub. So they avoid transmission. So that is how the collision is detected in the star wiring approach. So this is the general frame for a Mac frame, that is the Mac control. Okay, that Mac control will have the Mac header and trailer, including um, that which protocol you are using, what will be the length of that protocol and other things that will come under this. So there is a destination MAC address, source MAC address, LLC PDU, because as I told you that this data link layer is divided into two parts, LLC and MAC. So it receives a frame from a higher layer, LLC, that comes to MAC. So it is LLC data, protocol data unit from the higher layer data that is coming from the higher layers, right? That we will see. Then the CRC to check any errors in the frame. So we can also divide the MAC protocols in this form. So random access, we will be doing on random access. Random access, we have pure Aloha, slotted Aloha, CSMA, CSMA CD, which is employed in Ethernet. Now, last one is CSMA CA, that is employed in wireless LAN. And there is a controlled access, that is polling and token passing. This we will see. Token ring, token bus is not in your syllabus. Polling, polling means what? Polling is like you have studied the roll call polling and hub polling. You have studied in the data communication. Their roll call polling means just like a teacher is calling each student and asking that, okay, do you have the answer? Do you have the similarly one station which is deemed to be a monitor station, ask each station whether they have any data to send or not. So that is a roll call polling. And if you remember, there was another polling scheme, that is hub polling, right? Just to decide who will transmit. So there will be a centralized node, so that, or a monitor node that will basically ask each station for, it will poll each station for any data to send, right? So that is polling. And token passing, we will discuss the token ring for this. And channelization, like frequency division, multiple access, FDMA, TDMA, CDMA, all those things, channelization you have, you must be studying in your digital communication. So this part we will not be focusing on, right? So can you say why CSMA CD, you know that CSMA CD is employed in Ethernet, while CSMA CA is collision avoidance, right? Carrier sense multiple access collision avoidance. So here we avoid collision, right? We do not detect the collision, rather we avoid collision possibility to the maximum extent, right? So this is employed in your wireless LAN. Can you say why can't you use CSMA CD as a MAC protocol for the wireless LAN? What is the difficulty in using CSMA CD as a MAC protocol for wireless LAN?
So collision detection will be difficult in wireless LAN because it is not always connected to the medium. And
it is not always connected to?
No. So maybe sensing that the signal strength has increased in the medium, that is not. Maybe.
Yeah, you are right, because we have dynamic range of signals. Okay, so as the signal travels, the signal strength falls off. So, and so that is one of the reason that you are correct, that the detection of collision is difficult, right? Because of the dynamic range of signals. And another issue is that is a hidden station problem. What is that hidden station problem? Because in a wired LAN, you know that how many stations are connected, right? But in a wireless LAN, any station can turn on any time, right? You are not aware, like you see here that this station B and station C, they are, see, this is a wireless range, right? This is a wireless range of A, right? So A, which is in wireless range of B and C, so they know that if any transmission from A is resulting, that will be heard by station B and station C also, because they are coming in the wireless range of A, right? But A is completely, because D is not in the wireless range of A, right? Not in the wireless range of B, but D is only in the wireless range of C, right? So any transmission from station D will not be heard by B and A, right? So suppose if A transmits something to, you can see that if suppose A transmits something to C, right? So once A is started transmission, B will hear that station A has initiated transmission, so it will not start transmission. Station B and station C is also hearing this transmission from A, so it will not also initiate anything. But station D, which is completely unaware of the presence of A, right? Or vice versa, that A is completely unaware of the presence of D. So it may also initiate, it may also start sending something to D, and that may result in collision at this place, right? So this is a kind of a hidden station problem that may arise in case of a wireless LAN, because any station, because what is wireless? Suppose you will be using your device in your hostel, and then you move to the main building, right? And you will be using the wireless LAN of the main building. So anytime any device may turn up, okay? So you do not know about how many stations are there, and uh, so this results in collision. So this also puts a foundation on using CSMA CD as a MAC protocol. So hidden station problem. Then because as I told you, in CSMA CD, another issue that it requires a very high bandwidth and costlier station to support hearing of the medium while transmitting on the network. Because I told you that in the case of a CSMA CD, the station which transmits, okay, the station which transmits keep on hearing the medium also, because if for any possible for any collision, right? Because the station is transmitting, so once it is transmitting, it keeps on hearing for any possible collision, because once the first bit reaches to the farthest end of the network, that is fine. Then no station will, because all the stations will know that already some transmission is going on, so they will not start transmitting. But if any station initiates transmission at this point of time, then a collision may occur. So this station, while transmitting, it keeps on hearing the medium. So that requires higher bandwidth requirement and costlier stations to support that while transmitting on the network. So that these, because of these reasons, CSMA CD cannot be used for wireless LAN, right? Now there are two. So this is the flow chart of CSMA CA. So you can see that how does it work? See, this is referred to as collision avoidance, right? Any possibility of the collision to be avoided. So what happens initially? See, this is what an IFS time. IFS is nothing but interframe space time. I will tell you what is that. Okay. So suppose initially a station senses the medium. Okay, just like it is what carrier sense multiple access collision avoidance. So station has to first sense the medium, if once it finds it idle, okay, here it finds that the medium is idle, but the station doesn't transmit, okay, even though it finds the medium is idle, but it doesn't transmit, assuming that some other station at the farthest end might have initiated the transmission that has not reached to this particular station. Are you following? The station senses the medium and finds that the medium is free, but it doesn't transmit, assuming that some other station at the farthest end might have initiated the transmission and it has not reached to this particular station, because you have to avoid collision, right? Any possibility of the collision. So what it does, it waits for an IFS time, interframe space time, right? So it waits for an interframe space time. There are different types of interframe space times that we will discuss later. Then it waits for an IFS time and then senses the medium again. Okay, it finds that the medium is idle, but then also it doesn't transmit. It waits for another period, another random period of time. That random period of time is nothing but a binary exponential backoff, right? It chooses some k slots because this is a contention window. So it chooses the number of slots it wants to wait. It chooses a random number of slots it wants to wait. And then it waits for that period of time. And then if it finds the medium is free, it sends the frame, right? तो इसमें बहुत सारे ifs and buts भी आ सकते हैं. जैसे if you say that what will be a possibility that if it is sensing it after IFS time and it finds the medium is busy, then what will it do? What the station will do? And in that case, if it finds that the medium is busy, right, it will keep sensing the medium till the medium becomes free, and then it will wait for an IFS period of time, and after that it will check if the medium is free. Are you following? Because if it is checking after IFS time and it finds that the medium is busy here, right, it will go back to this position. It will keep sensing the medium till it becomes free, and once it becomes free, it will wait for an IFS amount of time, and then once again it will choose a random number of time slots, and in between each, at the end of each time slot, it checks the medium. If the medium is free, it waits for another time slot, right? Because if it has chosen k slots, so it will, at the end of each time slot, it will check for the medium to be free. If the medium is busy, it will wait for the medium to be free, and then it waits for the random time slots. And once it finds at the end of the contention window, it finds the medium is free, then it sends the frame, right? And it waits for the acknowledgement. If the acknowledgement comes, it is, the frame is delivered successfully, otherwise it gets timed out, and once again for retransmission the same strategy is followed, right? So this CSMA-CA basically, when I say as a MAC protocol, there are two provisions in CSMA-CA. There are two, means the MAC layer is divided into two parts. One MAC part takes care of the streamy traffic. The traffic can be characterized as streamy or busty, right? Streamy traffic means which is like जैसे आप कोई real time traffic देख रहे हो, कोई movie देख रहे हो, right? In online you are watching some movie, right? So that is basically a kind of a streamy traffic. Some kind of messages, mails, they are an example of busty traffic, which doesn't require the medium for a longer period of time. They require only for a shorter period of time, while the streamy traffic require more access to the medium. So the traffic is characterized based on the streamy and busty traffic, and this CSMA-CA has a provision for two MAC protocols inside it. Means it divides the MAC functioning based on the type of traffic. Okay, so let us see the flow chart of it. So K is again the number of attempts, TP is the maximum propagation time, TB is the back off time, right? And there are basically three IFS times, interframe space times. Short IFS, and this is basically based on the MAC. As I told, there are two types of MAC exist for different types of traffic. It is called as a point coordination function interframe space, and this is called as a discrete coordination function interframe space, right? So this is basically used, this SIFS is basically used for acknowledgement, immediate responses, right? For immediate responses like sending acknowledgement and a time gap between while the handshaking is done, like request and then clear to send. So for that period of time, for immediate responses, this short IFS is used, while this point IFS and DIFS is used during this MAC functioning. We will see that how. So there are three interframe space time: IFS, PIFS, DIFS, and if I say the time interval, which one is larger, right? SIFS is the smaller one, as you can see. SIFS, PIFS, and DIFS, right? So it is used for immediate responses, SIFS, and it is the smallest time interval. अच्छा आप बताओ कि if you have to wait for 5 minutes and your friend has to wait for 10 minutes, who has the priority? Who will be waiting for 5 minutes? So similarly here also PIFS, which is having a smaller time period. So the station which uses PIFS as a MAC protocol will always get a preference over the stations which are using DIFS, because DIFS time interval is higher than PIFS, right? So let us see first this flow diagram of this CSMA quickly, and then we will come back to this discussion. Okay, so this in the flow chart, we again number of attempts, K is the number of attempts. So initially it is 0, and then the station senses the medium, it finds the channel is idle. If it is not idle, it keep on waiting for the channel to be idle, and then if the channel becomes idle, it wait for an IFS time, as I told you, assuming that some other station has already initiated the transmission which has not reached to this particular station. It waits for an IFS time, still idle. If it is not idle, then once again it goes back and keeps sensing for the channel to be idle, and once it finds idle, it will wait for IFS time. So if it is not idle, this will go back here. But if it is idle, yes, it choose a random number r between 0 to 2 to the power k minus 1. So how long it will wait? Okay, because this contention window, it has to choose some slots for waiting. So every time it finds that the channel become busy, so at this period of time, suppose if it has chosen some value of k is 0, so it waits for chooses a value of r, because based on the value of k, so it chooses 0 to the power k minus 1. It waits for r slots, and after r slots, if the medium is idle, it sends the frame, and during each time slot, at the boundary of each time slots, it checks the medium. Okay, it checks the medium. If the medium is idle, it is okay. If the medium is busy, it stops and wait for the medium to be free, and then it waits for the remaining time slots, and once the medium free, then it sends for this frame. It sends the frame, and it waits for the timeout, acknowledgement is received, yes, it is success. No, if no acknowledgement is received, it might be a collision, right? So it increases k to k plus 1 because there is a maximum number of attempts that a station can retransmit. Okay, maximum number of times. If it has exhausted its maximum attempts, it will give up. Otherwise, it will once again goes back to this position, right? So so this is about CSMA CA. These details of the MAC protocol, okay, like how it is implemented in wireless LAN, that we will do when we will study the wireless LAN part, right? जब हम लोग वायरलेस LAN करेंगे तब करेंगे इसको. Any doubt in this?
No, sir.
The token passing, there are three schemes under token passing. As I told you that so we have finished this random access. Now in the controlled access, polling, I have already told you that you have it studied in your data communication. Okay, and so we are not doing it. And token passing, there are three: token ring, token bus, FDDI. Token bus is not in your syllabus, so we will be leaving it. So we will be doing token ring and FDDI, right? And after that, there will be you can prepare for quiz because there will be first quiz, okay, after some time, okay, next week. Okay, so I'm stopping here. Any doubt is there, you can ask.